and welcome. We're coming back. Sorry for the delayed start. We had a little bit of a technical problem as my computer crashed right as we were launching. So a few minutes late getting going today, but appreciate your patience as we get ready to launch. So again, welcome to Westmont College. We're broadcasting live from Santa Barbara down in Winter Hall. This is the Computer Science 30 class. Working on developing some basic computer science skills with Java. Welcome to all our folks visiting remotely as well as the people present. Shout out today to Amy and James and Nicholas and Flo, who are hopefully visiting from afar. This class is part of a 5-week class that we're offering over Mayterm, and today's lecture is scheduled for 2 hours. We're communicating live on Slack on hashtag broadcast questions if you are connected to our Slack channel. And I think that's pretty good. So let's just take a minute to arrive. Let's turn off our notifications and cell phones and just remind ourselves that we are in control of our attention, and make sure I got to do the same thing for me. It's unfortunate. We got to arrange our environment so that we become the people we want to be and put our attention where we want to go. So yesterday we talked a little bit about the difference between something maybe being legal and something being acceptable to God or holy, and the difference between those two things, and the way that legality gives us a certain baseline for what might be acceptable, but the legal guidelines aren't necessarily the standard to which we're called. And we looked at a bunch of statements from Jesus' Sermon on the Mount that said that. I just want to highlight one that we already looked at. And this verse in Matthew says, "Again, anyone who says to a brother or sister, Raka, is answerable to the court. And anyone who says, you fool, will be in danger of the fire of hell." Now, in this context, this word has translations that are something like worthless or useless or cursed. And there was some sort of a legal binding understanding in the society at that point that if you actually said that to someone, there was a legal penalty for it. And so when Jesus is drawing this out, he's making the point that, yeah, there's this law about saying insulting someone this way, and that's not legal, and you're bound to that legal requirement. But in fact, my standard is higher. I think that if you said anything, for example, you fool, that is also less than what I would call you to. And so this is an example where the legal requirement and the level that Christ calls us to are different, and he's calling us to a higher standard in this case. And again, we looked at that last time in the context of, okay, what happens if you find yourself on a computer system and you encounter someone else's password because they're storing it in a file and that file is publicly available? Sure, technically they put their password in a place where you could find it, and so you didn't have to break into anything maybe to get it, and now you have access to their password and you can use their password to access their stuff, and you didn't have to break any laws in order to do that. And yet, there's sort of something that seems not quite right about that. And I think that's the kind of thing that you encounter a lot in digital environments, this ability to do things where you maybe didn't have to break a law, or maybe there isn't a law in place. And we just have to be really careful about keeping ourselves to a standard that we would be happy to face each other, face the public, have it in the Washington Post, face God with the actions that we do. In this particular case, I can't help but think of the social media that we have around us and the ways in which this actual text is saying that we shouldn't be insulting one another. And with social media, the way it is, it feels like pretty much every conversation on social media is someone insulting someone else. And it's interesting to think about that and say, well, wait a second, here's Jesus saying we shouldn't be insulting anyone else, and that's my standard, you fool. Don't say you fool. And yet I kind of see it happening all the time in my social media feeds. So take a step back and say, well, wait a second, how should we be handling ourselves anywhere? Social media being one of those places. And is there a way that maybe technically we could support that behavior? Like, is there something we could do as people that write code that would encourage social media to be a place that's healthier and maybe more Christ-like, in that it doesn't allow one another to call each other fools? Something that we as technologists have the ability to think through, And those are values that we can bring to the table. And we can say, hey, this is a value that's important to me, and I want the software that I work on to reflect that. So some of the things that you have the opportunity to work on as we go forward. Thoughts? I know I've talked to lots of students recently who are just sort of trying to figure out how to do social media. They're off of social media for Lent, they're back on, they've dropped one particular social media, they picked up another one, they've cut friend lists and just had people they interact with actually in person. So it's something that we're all working with. It's something we're all trying to figure out, how can we do social media in a way that's healthy and supports who we want to be. I'm doing it as well. So, okay, so for today in our class, just administratively, where are we? We have a quiz on Chapter 1 that's due tonight. Anyone having trouble with that, or is it working okay on Canvas? Okay. Quiz on Chapter 2 due Monday. Chapter 1's Introduction and Overview of Java. Chapter 2 is Using Classes. Quiz on Chapter 3 is due next Friday, and we have a programming assignment also on Chapter 3 due next Friday. And we'll touch base on what that is at the end of the lecture today. So just where we are. Last time, we looked at some things. Among other things, we looked at method calling and arguments, how we call methods in our classes, where the arguments go. We looked at methods and the way they return a value, and also how they have side effects. We looked at the difference between being an application programmer versus being a systems programmer, how we can use a class, and when we use a class, we're acting as an application programmer. And when we're implementing a class, we're acting as a systems programmer. And we do both of those roles all the time. We leverage other people's classes, but we also write our classes that we might want to use, or we might write classes that we want to share with other people as well. There are mechanisms to do that, but we haven't talked about them yet. Then we created a rectangle class and we created a circle class. We implemented them, and then we also wrote another class that used them as well. And we started to get into testing them. And so where I'd like to start today is going back to this testing environment and trying to work through that together and make sure we understand how testing works. Before we jump into the new material, any questions about what we covered last time? I know during office hours, one thing we talked about was packages a little bit, just handling that. Packages, again, are just a directory structure that help Java define the classes everywhere. Anything online, folks? Okay. So the first thing that I would like to do is I would like everyone to install a tool in Eclipse called, I call it EclEmma, but it might be pronounced maybe EclEmma or something by the people that actually developed it. I kind of like the way EclEmma sounds. We looked at this, or I kind of showed it to you briefly at the end of last lecture. What this does is it enables you to run your code in a special mode called coverage mode. And when you do that, this plugin keeps track of which lines of your code get run during the process of either running your code or testing the code. And then when you're done with the run, it'll color code all the source code with red if that line of code was never run, green if it was run, or yellow if it was partially run. So you can use this tool to run your code, but the time when I find it really helpful is when we're writing tests, because it helps us to see whether or not we actually tested a particular method. When you run it, it looks kind of like this. And so let me just, what I'm going to do is I'm going to kick out of the slide deck, and I'm actually going to go to Eclipse. I'll show you it running, and then we'll take a pause and give everyone a chance to install it and help you out. All right, so leaving the slide deck and then going to Eclipse. Last time we were working with this rectangle class, and this rectangle class was one that we implemented. It was just something that captured the idea of a rectangle having an origin, a width, and a height. One thing that happened between last class and this class is I went ahead and I added a bunch of setters to the class as well. So Eclipse provides this outline over on the right that helps you to see all of the methods that you've currently implemented in the file that you're looking at. And if you want to jump to them, you can actually just kind of click over here and it'll jump immediately to the method that you're interested in if you want to get places quickly, especially when you have larger files. That's helpful. The reason why I show you this, though, is because we also wrote this rectangle test class. I'm going to drag this over here. Remember last time we had our teaching moment with our inability to write scientific numbers correctly. And what I'm going to do is I'm going to create a new test class by copying the one that we've got here, putting it above, giving it a different name. And I'm going to do nothing in this test except for constructing my object. And because it's doing nothing in this test, there aren't actually any tests present. I'm just going to use code coverage in order to, oh, here, I'll add a test just so we make sure it works. So what we're going to do is we're going to assert that the following is true after creating our object. We want to make sure that R is not equal to null. What that means is that our constructor worked and we got an object back through the process of calling new rectangle. Now what I'm going to do is I'm going to right-click on this method name, and I'm going to go down to coverage because I have EclEmma installed. I have this as an option. If you don't have it installed, you won't see it. And I'm going to run just this one method as a JUnit test under coverage. And you'll see that everything got color-coded. Now what I'm interested in is over on the left side. You can see that as I ran this test, what code got run? Well, primarily the code associated with the constructor because I called it right here. If you look down here, none of this other code ever got run. Well, that makes sense because all I did was call the constructor and then tested whether or not it's true. If at some point here I did another test and I said assert equals, I want to make sure that 1.0, spell it right, that 1.0, get it working, is the same as r.getX because I want to make sure that my constructor did what it was supposed to do. Because it's a double, I have to give it a tolerance level there. When I now run that same JUnit test, I'm going to rerun it by hitting this green button here. Save my code. You can see that getX now turns green. GetX turns green because I added new code over here that called the getX function in order to test it. So one good goal for writing tests is to make sure that when your entire test has been run, all of your code is covered in green, because that means that you did some test that validated that that code was working the way you meant for it to work. All right? So what I would like to do now is I would just like to pause for a moment and get everyone installing the EclEmma code. Well, let me just get a quick indication from the folks here in the room. Does everyone have it installed? Does anyone need time to install it? Who doesn't have it installed? Okay, good. So then what we'll do is we'll take a 5-minute break. We'll come back at 42 with EclEmma installed. And what we're going to do is I'm going to ask one of you to write tests for Circle class. And I'll guide you through it, but have you do the typing and so that we can work through some of the confusion that might come up along the way. Okay? All right, so break until 42. we're coming back. And while we were gone, we installed the EclEmma tool. Some people needed clarification that the way that we did that was under Help and then the Eclipse Marketplace. And once you get the Eclipse Marketplace up and loaded, you can type in EclEmma here in the Find. And it should go out and find it in the store, the Eclipse store. It's free. And in fact, the versions of Eclipse that we had installed, many of us already had it installed. So maybe this was something that didn't need separate installation depending on the version of Eclipse that you downloaded. All right, so now what we have is we have this circle class that we worked with last time. The circle class encapsulated the idea of a circle. And we decided that the way we were going to represent a circle was with a center point, X and Y, and with a radius called radius. Those three things are going to be doubles, and they're private. And so what we would like to do now is we would like to write a test for the circle class. And while we're on break, we had a random number chosen, and Joy won the luck of the draw. So what I'm going to do is I'm going to work with her, and we're going to write the tests together. So Joy and I will share the project. Would the rest of the folks like to follow along through Saros? Yeah, okay. So what I'll do is I'm going to share, everyone come up on Saros. I'll share the project with everyone, but I'll make it read-only for everyone but Joy. And then I'll talk you through it, okay? Okay, good. All right, everyone's coming and going. Here we go. All right, sharing the project. We're going to be sharing the circle project. We're going to be sharing it with these folks and Boaz if he comes online. Presumably he wants to. All right, you guys should get a request, or you should get an indication that you're having a sharing initiated. And for everyone except Joy, I'm going to make it read-only. All right, one more. All right, syncing okay, Joy? Okay, now I am going to follow you. See what you're typing. All right. So the first thing that we need to do in order to write a test is we just need to think, what is the class that we're going to be testing? So what's the class that we're testing? Circle, great. And in order to write a test class, what we do is we have to make sure that our project has JUnit installed. If you look over on the left, it doesn't have JUnit installed. We could manually add JUnit right now if we wanted to, but in the process of writing this test, Eclipse is going to offer to install it for us. So we'll have Eclipse offer to do that. All right, so if you right-click on source in the left-hand side here, and you select new, it's not going to show up on my screen, new, and then JUnit test, and I'll show you what I would do right here, but I won't click on it. You should get a wizard that comes up, and what do you see in that wizard? So it should do something like ask you for a name of the class. And is it suggesting? Okay, we'll just follow through. Let's see how it goes. What we want is we want to make sure that the class under test is the circle class. And we want to make sure that the file ends up getting named circle test. And those should be options in the wizard there. It should default to that. You want me to take a look? Okay, hang on. So just close your wizard. Okay, I'm going to walk through it up here so that people at home don't run into the same problem, but we're going to right-click on source and do new JUnit test case, have it pop up. All right, so up here you get to select which version of JUnit you want. JUnit 5 is called Jupyter. The source folder is where in your project you're going to place these. That's fine. We actually have a package that we're working with, so edu Westmont utility. We're going to go ahead and select that package because we want the same package as the class that's under test. Okay. What are we going to name this test? Well, actually, I'm going to come down here first and indicate which class is under test. And I'm going to type something in so that it gives me a prompt. And then I'm going to name the test circle test. And I do that so that when it's listed alphabetically, they'll be right next to each other. And then next gives me, it would offer to stub out some of my methods, but I'm just going to skip that for now and hit finish. And this is what I was talking about. Because JUnit 5 wasn't on the build path, it's asking me if it wants me to include that, and I absolutely do. All right, so now circle test come through okay for you? Should be synchronized. I'm going to put them side by side. Okay, so the first thing that we would like to do, Joy, is we would like to make sure that our constructor works. So in that test that starts at line 10, let's go ahead and delete line 11 so that we don't have our test fail. That would be something we'd rather not do. So you can just do it in yours. Don't worry about what my screen's showing because I'm going to be synchronizing. But in the circle test file, there you go. Line 11, let's delete that. Okay, and let's create a new object of type circle by first giving the type. So the type's going to be a capital C circle. Pick a variable name that you like. Well, as is good for variable names. Variable name? Larry. Okay, and then use the assignment operator, equals. And we'll set that equal to, we want a new object. So we'll use the new keyword. And then we'll call the constructor, which is capital C, circle. And then there are 3 parameters that circle takes: the origin, which is x and y, and the radius. Now this is up to you to pick because we're just going to test whether the constructor works. So go ahead and pick an x and y and a radius. All right, and put a semicolon at the end. All right, so now as I look at this, a couple things to clean up. First of all, in the very beginning when you did circle.Larry, that's the notation for going into the circle object, and we just want to use it as a type. So we should replace that with a space. Perfect. All right, the other thing that I would do is I would change your 3, 7, and 19 to be doubles and just add a 0.0 at the end of them. So 3.0, 7.0, and 19. No, that's okay. You just need to make it, by putting the period in there, you're telling Java that you want this to be interpreted as a double, and you don't want any, you don't want it to do any typecasting for you. Okay, so now that looks good. So what is it that we would like to test in our code? If we run this now, I'm just going to go ahead and run it on my computer so you can see it. If we do coverage as a JUnit test, we'll see that our constructor gets called, but we're not actually doing any tests of anything yet. So let's go ahead and test to make sure that our constructor correctly saved the x value. So to do that, we're going to need to call getX on Larry. And before we do that, what do we expect x to be when we call getX? 3. Okay, so we're going to add a test to it. A good test here is we're checking to see whether it's equal. So yeah, there you go, Larry.getX. All right, so now we're going to put that in the context of a method call called assert. And so that what you just typed is going to be the first parameter in a method call, and the method is called assert. So at the beginning of that line, type assert equals. Capital E. Go. Good. And Larry.getX will be the first parameter, and then the second parameter is it's not an assignment, it's a method, so a parenthesis. There you go. At the end of the line, what it is that we expect, the second parameter is going to be what it is we expect x to be, so 3.0. And then because we're checking the equivalence of floating point precisions, we need to say how close does it have to be. the infamous epsilon. So you just type capital epsilon, and I'll throw an epsilon in up here for us since I now know how to do it really well. Okay, go ahead and capitalize epsilon. We use capital letters to designate that it's a constant. That's a convention. Capital letters are a constant. And then put a semicolon at the end. Great. So you've written your first test. If this passes, then we have pretty high confidence that our constructor did a good job at storing the x value. And you should see over on the left that getX is going to be green now. It wasn't green. What happened? Let's try closing it and reopen. I did run as or coverage as. Let's try that again. Let's just go to the JUnit test. Circle test. We want to do coverage as JUnit test. There we go. So now getX got colored green. And what have we actually verified? We verified that the constructor stores the x value correctly, and we verified that getX returns and does the code that we expect it to do. So this makes us feel really good about our constructor so far. So let's go ahead and cut and paste that line 2 more times, and instead of getX, let's do getY and getRadius, and replace 3 with 7 and 19. Okay, perfect. Okay, so now you've written a test that's going to test x, get y, and get radius. Just rerun it. Let's save everything. Rerun it. And while you were typing, I introduced an error into our code. What I did is we'll call it a typo. And if we look over here in our code, let's see, can you just click somewhere else in your code, Joy, because you're overlapping my colors. You're somewhere else now? Okay, well, let's see. So what's happened here is that our get y has failed, and we can see that another way by coming over here and seeing, oh, look, here's my failure trace. Something in my test went wrong, and if I double-click here, it'll take me to the line of code that went wrong, so the second line down. And you can see that this test failed. So I ran these things thinking that I wrote really good code when I was writing my circle class, but when I went to test it, get y didn't return the right value. And if I come over to my code, I was like, well, why didn't get y write the correct value? Well, okay, there's something wrong here. I need to actually return y. And what if I made a typo and I did x accidentally? And I rerun my code. Oh, it's still not passing. My tests aren't green over here. And if I come here, it shows me that that I expected 3, but it was 7. That's because of the order here. In order to get these words to line up correctly, you actually have to put your expected value first. Let me just switch that up for you. Equals is equals. It doesn't matter which side of the equal sign something is on, but when the error messages come out, it's helpful to have it tell you the right thing. JUnit expects the left thing to be what you expect and the right thing to be the item under test. We try again. All right, and we look at the error and it says, oh, we expected 7, but it was 3. We double click here. We can see, oh, okay, something went wrong. We expected 7, but it was 3. So we expected 7, and when we called get y, it was 3. And we go over to our get y code, and we see, oh, look at that. We made a mistake. Instead of returning y in our get y, we returned x. That's just a completely normal kind of bug that you might encounter when you're typing code. And the reason why you write the test code is to make sure that you didn't make bugs like that. So if we change it back to y and we run it, our tests all pass, and we feel a lot better now. we feel a lot better about the code that we actually ran, but you can see we're not running all of our code. So let's finish writing tests so that we test all these different elements out. So the next thing that we would like to do is let's try changing all of our x, y, and radius and see if that sticks. So that's going to be equivalent to calling set x, set y, and set radius. So after line 16, let's go ahead and call Larry.setX. And instead of x, give it a new value for something different than 3 that we can check to make sure it worked. 18, great. Make it a double, so make it 0.0. All right, and now do another line right under that. Do Larry.setY. And give y a new value different than 7. Good. And then do a last one, Larry.setRadius. Give it a new value different than 19. Do 3 on the same line. So the question is about the semicolons, and so this semicolon here indicates the end of the line, and so it would be fine. It would be fine to just, for example, do. It's hard to read, but it would be legal to do that. That's what you mean. So that's legal, but it's sort of formatted. It undoes that. You can put extra ones in too. That's just empty lines. Okay, so Joy, let's copy lines 14 through 16 and paste them down below 19. So now we're going to test the get x, get y, and get radius again, but now we want to change the expected value to be 18, 21, and 23. Great. We save those, and now if we run our test, we'll see that we have much more coverage over in our class on the left. All of our getters and setters, all of our accessors and mutators, except for the ones at the bottom, all have some code coverage now. So the last thing that we need to do in order to complete our test of our class is to make sure that get area and get circumference are what we expect. So we know that what we want to do is we want to figure this out without looking at our code. We don't want to cut and paste our code over from the left side to the right side, because then if there's an error there, we're going to just transfer that error. So we want to think. We know that area is pi r squared, and so if we made a circle that had a radius of 1, then our area should be pi. So let's do an assert equals, where the expected value is math.pi. Capital M, yeah. And capital PI. And then the second parameter is Larry.getArea. And then give it a tolerance of epsilon. Now again, you only have to add the tolerance of epsilon if what you're testing are doubles. Integers you can compare exactly, and strings you can compare. Okay, good. All right, now if we run that, what happens? Doesn't actually pass. Why didn't it pass? It's not 1 yet, right? That's the way objects work. What we expected was pi, and what we got was 1,661. All right, so what do we have to add before line 23 so that our test, so that we get the expected value? We need to set our radius to 1.0. Great. And now if we run it, great. We passed get area, and area got coverage now. And the last thing we have to do is do a similar thing with get circumference. And so we think to ourselves, the formula for circumference is 2 pi 2 pi r, right? 2 pi r. And so we should be able to just cut and paste that line because it should be pi 2 pi r. No, you're right. You got it, Dre. All over it. The only thing I would do is I would change your 2 to be a 2.0 to make sure you don't have any sort of conflict with integer. There you go. Great. Now we run it. And we have complete code coverage. That's really great. It's not a guarantee that our class is perfectly implemented, but it gives us a lot of confidence because what we've done is we've tested every single method in our class, and we know at least in some instances that we have the right answer coming back. And so now we feel like, okay, now I'm willing to have my boss look at this. Now I'm willing to have the code coverage go live. And you can get a little bit more information if there's a tab over here for code coverage if you want to look at it. You can look and see of your source files what percentage of your classes actually got run in the last run. So you can see you got 100% coverage. Now, in practice, trying to get 100% code coverage is really more effort than it's worth because there are a lot of cases in real software projects where getting 100% code coverage would require too much infrastructure. What you want to shoot for is well, it's always a trade-off between time and basically time and effort, I suppose. Oftentimes, you'll find yourself in situations where if you are obsessive-compulsive code tester, like I find myself to be, you end up getting about 85 or 90% code coverage. There are maybe some areas of your code because of the way you've structured it that it's actually impossible to run certain bits of code. You know, for example, if you just said if false, print out hello world, well, you're never going to be able to print out hello world, so you're not going to be able to get 100% coverage. That's a trivial example because why in the world would you ever put that code into your software? But there are other examples where the flow through if statements, etc., make it difficult to avoid some dead branches in your code. All right, thank you, Joy. That was great. I would give you a round of applause, but that's sort of weird online. So, good job. All right, so let's step back for a second. And I want to make sure that one aspect of these objects is clear to you, and that's how references work. So I've been saying object references. I've been saying these variables are references to objects. And it's important to understand how those can be used in practice. So if you look at this code here on the left, I want to point out the fact that when you copy an object reference, you actually can end up with two variables that are pointing to the same chunk of memory in Java. And so if we walk through this code and we assume what we have here is two objects, and when we start out, we have one object, maybe we say this is what A points to, and this is what B points to. And if when we I didn't put my code for the initialization there. I'll have to fix that. If B has the value of 2 for x, so we can put that there, and A has the value of 1 for x, perhaps, we start out with A and B being different objects. In the second, and so we print out b.getx and get the 2 there. In the second line, when we say b equals A, we're saying now that B and A point to the same object. So if A is pointing to this one here, and now B is no longer pointing to this object, but it's pointing to this object at the same time. So if originally we had 1 there, and then in the third line, we change that, and we put in 0. In this line here, now that we've called getX, the x that we're actually going to return is this 0. So what I want to draw your attention to is that we have set x here in the A object, but when we return it here, we see the effect of the set object being reflected in the B object below. So it's possible to create two objects, A and B, set them equal to the same object, and then change one and get the result at the same time. I feel like that's not totally clear, so let's just do that really quick in our circle example. So in our circle test, previously we had this hello circle project, we had a circle called Louis. And Boaz, give me a name. Yeah, I don't like that one. Try again. John. How about John? So I don't have to type so much. All right, so I'm going to go through and I'm going to spell it. At least I'm going to have to spell it consistently, however I do spell it. Yeah, that's the magic of VI. You can. What I'm doing is as I'm typing, I'm actually recording a macro of what I'm doing, and then I'm playing back the macro again really quickly. So like I'm thinking ahead, and I'm knowing what I'm going to do as I'm going to repeat it. So I hit a record key, and I record my keystroke, then I end record, and then I play it back. But you're not seeing all that happen as I'm typing. Okay, so if we run hello circle now, we should see the result of having two different circles. And we can see in our console that see that Louis has 17 and John is at 1, 0. And now if we come down here and we say, okay, well, John is actually going to equal Louis now. And I'm just going to print out the exact same data. But the difference is on line 21, I made John not point to its own object. I now made John point to the same thing that Louis points to. And so now when I run the code, you can see that the first time Louis has this data and John has this data. But then as soon as I change John to point at Louis, I lose this object. And now John and Louis are pointing to the same thing. So even though I'm calling getX and getY on John, I end up getting the same value as what Louis has. And likewise, if I come down here and I say John.setX equal to something we'll remember, like 99, and then I print out the code, print out the contents of Louis, you can see that I set 99, I set X to 99 in John, but the result is that Louis has changed. And also John has changed, because both of them are pointing to the same object. Okay? So this is an important thing to realize as you start working with objects, that it's possible that you could have two objects that are actually two different things in memory, and they have instance variables that are each independent, or you could have two variables that are pointing to the same thing in memory, and you might be simultaneously modifying the same thing. Sometimes that kind of behavior, if you don't have the right mental model, can really get you confused about what in the world is happening. All right, so what this chapter is about constructing new classes. So we're going to go through and do a sequence of the construction of two classes. We're going to do a class method for like a counter that would keep track of attendance, and then we're going to do one for a bank account. All right, so let me describe what our class for our clicker class is going to do, and then what we'll do is we'll take a break just to stretch and get some water, whatever we need to do, and we'll come back and then we'll implement those two, and we'll just think through the process of writing some. This is in preparation for our third homework assignment where I'm going to ask you to write classes on your own. Okay, so our new class is going to be based on this idea, this abstraction of a clicker that you might count cars in a parking lot with, or people at a concert, something like that. And so what we want to do is we want to encapsulate the number of times that this object has been clicked. So we're going to have a constructor where we'll construct the object and we will initialize its counter to 0. Then we'll have a method that can increment that counter called click. And then we'll have a method called getValue that will return what the current counter is, so that we can find out how many people attended our concert or our parking lot, or how many hot dogs we sold, or whatever we're keeping track of. Our instance variable is probably just going to be a counter, because the only data we need to keep track of in this counter is the number. So that we can use an integer for that. No floating point. We're only going to have whole numbers, so we're going to be good for that. And in fact, we're only going to have positive numbers, but we'll just use an integer. Okay, any questions about this class before we take a break? Any questions about references? Any questions about our testing coverage? Anything online? Anyone on Slack got anything for us? Okay, then let's come back at 11:18, and we will pick up on making this tally class. Okay, we're coming back in, and we are working on making this new class, this counter class, and the idea is to encapsulate the idea of a clicker. So we're going to kick out to Eclipse and share a new project and try and pick it up, because this is a process that you do all the time, making new classes, and we're going to do it for our homework. So doing a couple examples beforehand should be helpful. The assignment is to make, no, we haven't described what for the assignment, you're going to make a class and then a program that uses the class, but it's not going to be the clicker. We're going to make a couple, though, so that we know. Making the class. The clicker is pretty easy, but we'll just make sure. Sometimes it's not quite as run into glitches along the way. I'm sorry, I made a new class, and what I need to make is a new project. Java project, clicker, great, and next. And I'm actually going to add a JUnit library here from the get-go, so that we don't have to add it later. As part of the wizard under library. All right, we've got our class ready to go, or we got our project ready to go. Now I'm going to make a new class, the clicker class, and put it in a package that I approve of. All right, and save that. Wants to move it to a new directory. Let's go ahead and move it to the right directory, save everything, and spell it correctly. Typos, put a semicolon at the end. Save it. There we go. Now we'll save it, share it with you guys. Sharing the wrong one. Updates, so share my project. Clicker, next. Boom, boom. Great. All right, so we said that what we wanted to implement here was a clicker, and we're going to need instance variables, which is a counter, and we're going to need a, I'm not going back. Sorry, there we go. We're going to need a constructor, something that clicks, and a value. All right, so that was our design. So we'll do this manually. So what do we know about constructors? We know that, let me send you all the read-only. Okay, so we know that our constructor has the same name as our as the class that we're working with, and so we're going to also need to think about the scoping of it. So we think, do we want application programmers to be able to make a new clicker? The answer is yes. That's why we're making it. So we're going to go ahead and use the public keyword to describe our constructor. A constructor doesn't have a different return value than itself, so a constructor just returns the object itself, and so we use the object name as the name of our constructor, both to indicate that it's returning a clicker object, but also to indicate that it's a constructor. And so we'll say that this constructor is going to take no argument, so we'll leave that blank, and we'll stub it out with our curly brackets. Whoops, and then we'll do that, and I'm not sure what that was about. We need to give it our parameters again. All right, and well, let's see, what else did we say we needed? We needed a click method, and our click method is something that we want other people to be able to call, so we'll make that public. Click, when you call click, by design, do we want it to return anything? What should it return? Right, so it's going to change the state of the object. We don't need it to return anything. It's just going to have the side effect of incrementing our clicker. So the return type will be void. We'll call it click, and it will also take no parameters. And we'll just leave it blank for the time being. And the last one we want is going to be public as well. It's going to be get value. When someone calls get value, do we want it to return something? Absolutely. We want it to return whatever where our count is currently at. We're going to keep track of that as an integer, and get value, and we're going to get a little error here because we don't actually return something. And Eclipse says, hey, you said that this method returns a value, and you're not actually returning anything, so I'm going to put a little error here that says, you must return a result of type integer. But what we've just done here is we've just stubbed out our class, stub. What we've done is we've written down all the methods that are going to be part of our public interface, and this is part of the design process. Often it's helpful to just go through the process of writing out your methods, what the return types are, and actually, in order to get rid of your bugs, sometimes you'll just do something like this, just to make sure that you can see it clearly without getting distracted by the bugs. You say, okay, this is what we want our class to be like, and now that we have it present, we can go through and do the implementation. So as part of the design process, you think about what you're doing, what you're encapsulating, what you want the behavior to be, what the methods are that you're going to implement, and then you think about, well, how am I going to actually achieve that? Well, clearly, we're going to need to keep track of how many times the clicker's been clicked, and so we'll do that with an instance variable. Do we want that to be public or private? What's your rationale? Right. That's right. We don't want them to be able to access it on their own. The goal is to encapsulate this idea of a clicker, and we don't want people outside of our, we don't want people that are using our class to have to think about, nor do we want them to have control over how we implemented it. So that if in the future we want to change the way we implement it, we can. And we don't have a problem with that because no one is accessing our internals directly. Right? So we're going to go ahead and implement it as an integer. And we'll call it count, maybe. No, let's call it clicked. So in our constructor, the thing that makes sense, we know this from Python, that typically what happens in a constructor is you go through and you initialize all of your instance variables. It's good practice. It's not the only thing that you do in a constructor necessarily, but it's what we'll do here. So we'll say when we first create our clicker, we'll set our clicker equal to 0. That makes sense. It reminds me that maybe it would be helpful at some point to have another method that manually resets our clicker. So should we add another method that's reset? Okay. Okay. All right. Since clear is going to just set clicked equal to 0, and I don't like having duplicate code because I don't like if I make an error somewhere to make the error in 2 different places. In my constructor, I'm actually going to just call clear, so that I only have one place where I'm setting stuff equal to 0. Backwards? Okay, sure. Do we ever want our counter to go less than 0? Okay, so we're going to need to put some protection in for that then. Yeah, we haven't gone through if statements yet, but it's just like in Python, except that we use curly brackets instead of indentation. All right, so let's go ahead. Click. We're going to need to update our clicker. Clicked equals clicked plus 1. Great. And unclick, we'll say clicked equals clicked minus 1. But we have this problem where we don't want it to go to a negative number. So we'll just throw a conditional here. If clicked is less than 0, what do we want to do if it goes negative? We just want to block it? Or just keep it at 0. Okay, where in our code do we set it equal to 0? Okay, so we'll just call clear. All right, get value. If we return 0, is that going to work? Yeah, absolutely. We don't want to return 0 every time. We want to return whatever we're keeping track of. Clear is pretty good. So that looks pretty good to me. How do we know whether or not that works? We better write a test. All right, let's do that. The new JUnit test case. That looks good. Finish it up. I'm going to put it side by side so that we can see both the code we're working with and the code we want. I'm going to make a new clicker. C equals new clicker. And what do we want to make sure is true about our clicker when we first make it? Okay, so we're going to assert equals that 0 is what we expect, and c.getValue better be equal to 0. I don't need to put a precision value in this one because it is an integer. I do, however, need to import assert equal. Oh. What's going on here? It's ambiguous. Okay, well, I'll tell you what, for the time being, let's bypass that and use assert true instead. That work? There we go. Okay. So we'll make sure that our value is equal to 0, and make sure that that comes out to be true. If we call clicker a couple times, 3 times maybe, now we better find that our clicker is equal to 3, right? All right, so that better be true. And if we call unclick, let's call it just once and make sure that that worked. Great. So this is going to test click, click, click. This is going to test unclick, but we haven't tested the behavior around clear. But let me show you what this does so far. If we run this as code coverage, we can see exactly what it is that we've tested so far. And I got to reopen it. Sometimes it doesn't refresh the way you might like it to. All right, so on the left is the code we've checked. Oh, we've got some yellows now on the left side. So we see that we did call unclick. We ran the line of code that said clicked equals clicked minus 1, but we never ended up running line 18. So we never tested that. Well, that's because we never had a situation where we tried to click something and made it go below 0. So we're gonna add to our test. Does that make sense? So if focusing on the left side, what yellow means is that it was partially run. So it means that it hit that line of code, but it only ran it in one condition, where clicked was greater than or equal to 0, and it didn't run it. It didn't stop. It kept running, but it only had one. So there are 2 ways in which that could end up being evaluated, either as true or false, and it only evaluated in the case where it was false. That's right. Nowhere in our test did we ever execute line 18. And so we don't have any confidence that the behavior associated with line 18 is working. And so what we're going to do is we're going to add a couple more unclicks. So at this point, our clicking was 2, so we'll make it go down to 1 and 0, and now minus 1. And we know that that better be stopped. So it better be the case that after unclicking enough times that it would go to minus 1, it better be equal to 0. Now if we go back and we rerun our JUnit test, we see that that got covered in green. So now on line 17 on the left, we ran both directions. We had it come out true and come out false, and at least in one case we ended up running line 18. And it all passed our test, so everything is behaving the way we felt like it should. And we ended up running all of our code, so we have pretty high confidence that this clicker is working like we expect it to. Yeah, I could do it manually as well. So let's, and that would be a good test to run as well also. But let's click it up 2 times. Let's make sure that it's equal to 2, which is what we expect. And then let's do clear. Make sure that it equals 0 now. So why is line 27 green before we wrote those tests? Yeah, it's used for the negative. It's also used in the constructor. But now we just called it directly, and it still passes our test. Line 18 here. That's a good question. So what I could do that would be fine is I could say this dot clear, and this is equivalent to what I had. And what that means is which is that everything? So that's the same way. On the right, I'm saying c dot click, and on the left, I'm saying this dot clear, or on the right I say c.clear, and on the left I say this.clear. This is always hard to describe because I want to use the word in a different way, but the keyword this is used within the context of within the context of an object, within a method, you automatically have access to the keyword this. This is a reference to an object that is of the class that you're currently writing. So this refers to an instance of the object. It is the object which is currently has the current, it's on the right side when you, I can never describe this very well. On the right side when you call c.click, you're going to be running a click method on a particular object with particular instance variables. Within the click method, this is equivalent to c. C and this point to the same thing. So remember when I said you can have two references pointing to the same object? In this, here I present to you an example in which there are two references that point to the same thing. One is this, and one is C. They're both pointing to the same object, but because the code that's shown here is run regardless of which object it is called on, whether it's clicker C or D or E or whatever we've got, within the body of the code, this is always going to refer to the current instance that's being executed on. And so it's a way for an object to refer to itself so that it can get access to the instance variables. But your first question was, how come you just called clear and it went here? What's that? Without this, it will call whichever method is in scope. So it will try and find clear, and the first place it looks is in the method. So it's just the way Java tries to find methods. It looks in the same object. It understands that it's a method, yes, but because I put parentheses after it. But in the same way, like when we access clicked here, how did it know where to find clicked? Well, it looked in the method for it. We could also say this.clicked. And we said, actually I ignored Boaz earlier, we said this was supposed to be private, and we do want it to be private. Okay, so if we say this.clicked, we get access to the instance variable here. That works because we're accessing it from within the method, and so private is, you're allowed to access that from within the method if it's private. But over here, if I try and access clicked directly by saying c.clicked, which refers to the same thing, you can see that I get an error because it's not visible, which means it's private. But if I come over here and I make that instance variable public, now line 28 should compile okay. Why is it? Insert variable declarators to complete local variable declaration. What in the world does that mean? Here we go. Okay, so I'm using it. So in this case, I'm printing it out, and I'm printing it out by going into the object directly and getting access to the instance variable. That's exactly the behavior I don't want. I don't want people who use my class to be able to access the internals of it, because I might like to change the way that I implement it. By making it private, the only way they can get that is by calling getValue. So they have to go through my method, a gatekeeper, in order to get access to the implementation. Now, why does that matter? I mean, this is sort of abstract, but let me show you why that matters. I just ran the test again. I made my internal variable private. You know what? I'm going to totally change my implementation now of clicker. Rather than keeping track of it with an integer, I'm going to keep track of it with a string. Now, this is a little weird. Why would you do this? It's to prove a point that I can keep track of it with a string. And instead, when I click, what I'm going to say is I'm going to say clicked equals clicked plus, and I'm going to keep track of a bar character at the end. I'm going to put a little vertical bar at the end of it, so that as I click things, I'll be putting hash marks like I'm in the prison cell, marking off days till my release. And if I unclicked, well, that's a good question. How am I going to unclick it? You have to, yeah, this is going to be, all right, let's see, this is going to be a little bit crazy. Let's see. Oh, that's easy enough. So I'm going to remove the first hash off the front of the string. Let's destroy it. I was afraid that was going to be much harder. And how am I going to get the value? Well, I'll say click.length. And when I clear it, I'll say reset equal to the empty string. I just totally changed the implementation of the clicker class. I'm not using numbers at all. I'm using strings. But if I run my JUnit test, something crashed. Unclick didn't work.
Going negative.
Oh, right, going negative. Nice. Okay, so what do we want to do? We want to say if clicked.length is greater than 0. Then we want to do this. That's why we do a test. Boom, we just passed all our tests. Did we change anything in our test? No, because everything that the test used was the public interface. This is so exciting. I love this one. This is so exciting. We didn't change anything in the public interface. The public interface describes a behavior for this object. Our test class tests that behavior. Our implementation is encapsulated and hidden from the outside user. So we were able to do it however we wanted to do it as long as we maintained the correct behavior. And the test saved us because the test demonstrated that when we tried to shift to a string, we didn't keep the same behavior. We started going negative, or we had an exception when we tried to make a substring of a string that was less than 0. So this is the power of using these concepts of being an application programmer and a systems programmer, and using the public and private keywords in order to separate the concerns about the implementation from the behavior of these two objects is a powerful concept. And that's really one of the main things that object-oriented programming brings to the table.
Put it back to where we substring.
Here?
Why does it start on line 19?
So on line 18, everything's okay. The value, oh, I see what you're saying. Okay, so what happens here? We have clicker is C, we have 0. We click, 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 the value is 3. Oh, that's a good question. We hit unclick. Oh, I think the error is on that line. Yeah, there you go. The error actually is on line 18. Line 19 is red because it's never run.
Okay.
Yeah.
Okay.
So 18 is the last line that was run. How about you just want to print it every time we click?
No.
Huh? That? At that point, there's nothing there, so it printed out an empty string. But how about when it was 3? Oh, sorry. So down in the console, you see 3 hashes. Make the string a private variable. If you make it private, the only way you can get access to what's internal is by calling getValue, and getValue returns an integer. Right, so you're only able to so the behavior of this object is, regardless of how you keep track of it, what you're going to get back is a number. You could keep track of it in clown emoji. You could keep track of it in taco emoji. You could keep track of it in floating points or integers, or you could keep track of it with an array of other clickers if you wanted to. It doesn't make a lot of sense, but you could, right? And so one of the goals of the array of clickers, but one of the goals of the implementer is to do it in the most efficient way you know how, so that when you call these methods, it's fast. Well, I love it, yeah. So let's send it back to the way that makes a little bit more sense, I think. Okay, and oh, and run the JUnit test to make sure I didn't introduce any bugs in it. Good, we're good to go. Okay, great. So let me break the connection there so you guys have a copy of that so you can take a look at it. All right, so that's a clicker class. We did a little tally thing. We might use that in different contexts to make the point about the fact that these things are actually references and could be references to different objects. Sorry for that. In our test, we could just as easily have taken all of this code and repeated it with a new clicker that we call D. Sorry. And we would run that code. We now have two clickers, one C and one D, and we have different values for them. And these are actually two different objects with their own instance variables within them. They both have their own counters. They're not necessarily the same. And that enables us to use the same code in two different contexts to keep track of two different instance variables. If we want to keep track of a parking counter and a snack bar counter, we would instantiate two different clickers and click them independently, and we would get different counts using the same code base, the same clicker class. And that's why we need the this keyword. Because as we do things like update our clicked count, we have to say the equivalent of this.clicked equals this.clicked plus 1, or clicked equals clicked plus 1 if there's no other confusing variable. And so we edit the internal variables of each of these things. It's like manufacturing a bunch of clickers, I guess. So each one of those instances had its own instance variables that were manipulated separately. And then just being aware that we can have two different references that either point to two separate clickers, or we can have references that point to the same clicker, depending on how we go about doing that. So you just have to be careful about that. So this whole idea, this fact that we can swap things out with a number or with vertical bars, is the idea of encapsulation. So encapsulation is the process of going through and hiding the implementation details, but providing methods to get access to the data that's internal. So in order to do that work, we have to declare our instance variables as private so that no one outside of our class can have access to them. But we declare our methods public, the ones at least that we want people to access, and we call that the public interface. And so encapsulation allows application programmers to have to use a class without having to know about how it's implemented. As long as the test, as long as the systems programmer wrote a test, it's all good. All right, so let's do one more. This is going to be a bank account method, and we're going to construct it. We'll make it so that you can deposit money in it, so that you can withdraw money from it, and so that we can get a balance. So kind of similar sort of constructor. What I want to exercise in this one is I want to introduce two new ideas: the idea of overloading a constructor, and the idea of how to do Javadoc comments. Okay. So let's see. I'm gonna do this one pretty quickly, and I'm going to skip the sharing bit for now, and I can share a copy of it afterwards if we want to just have it available. So I'm going to make a new project. I'll talk through it. It's a Java project. I'll call it bank account, and I'm going to make a new class in my bank account called bank account. And my bank account is going to be in a particular package. And I need to move it there. Save everything. All right, and the first thing I want to do is I want to make a constructor. And by default, my constructor is going to just initialize the value of the account to 0. That seems like what we've done before. So I'll keep track of, since we have cents, I'll use a double. I'll use this just to prove a point. All right, and if we want to deposit money, that's going to return nothing. But we're going to take a parameter, which is how much money that we want to deposit. And now instead of incrementing it by 1 like we did for a counter, we're going to say balance is going to be increased by how much. Do you guys know the plus equals syntax? That's equivalent to saying balance equals balance plus how much. Just shorthand for it. Good. Withdraw. That's right. It's not a reserved word. How much is going to be the application programmer will call deposit, and they will put a number as the parameter, and that number will be passed in as how much, and then we will receive that as a systems programmer as the variable how much, and we'll add it to our balance. And then when we're done with the method, it goes away. And we'll say the same thing, except withdraw is going to subtract it, and we won't put any protections against the balance going negative. We'll assume that you can hold a debt with the bank, and so we don't have to put checks on it. And then the last thing we'll do is we'll say, well, how much is present? We'll say get balance. And I didn't initialize it to a double, so I'm getting a little bit of trouble there. All right, we don't have any confidence that this works until we actually make a test that validates it works. I'll just do some basic stuff here and say we got a new bank account. Should be 0. So we're going to assert equals 0 and b.get balance, and it is a double, so we need a little epsilon. I used an Eclipse hotkey in order to write that code for me. All right, so that better work before I make any more tests. I'm going to go ahead and make sure that one works. It did not. That worries me. I tried to get my balance. My balance was not 0. Stack Overflow error. Oh, I've got some kind of a, oh, look at that. Yep. So get balance isn't working. There's some error in my code. I looked over on the left to see what the error was. It's a Stack Overflow error. Stack Overflow errors are an indication that recursion has gone badly, that you're calling a method over and over again and you're running out of memory. Like, what? I'm not using recursion in this class. What's going on? Well, the only method I called was getBalance. So let's go look at the implementation for getBalance. Return this.getBalance. So it just calls itself over and over and over again to return a value. Just a typo. What I should have been returning is this.balance. And I probably went too fast and I had Eclipse complete that for me. So even in like the most simple code, this test just saved me from a bunch of headaches because now I know where to look and what was wrong with my code. I love testing. All right. So let's deposit some money. Deposit $100 to my account. Now my balance better be 100. Then we'll withdraw some money. Withdraw 25. Now my balance better be equal to 75. And if we do that, we should see full coverage on our code. And I need to reopen to see that coverage. Great. All right, so bank account. We can now do a couple fun things with this. We could, for example, create 2 bank accounts and transfer money from one person to another. So let's say we've got Bob's bank account. You want to, so Tim, you'll like this. So you see the B? So there's Bob's bank account. We'll just put some money in there. And then we'll have Jill's bank account. And we'll put some money in there. And now what we're going to do is we're going to chain one of these functions together. We'll say bob.deposit Jill.withdraw 25. Ah, that didn't work because the withdrawal doesn't. My design wasn't quite right to do that. Because withdraw doesn't return anything. No, sorry. That wasn't as cool as it should be. Need a better design for that. So we're going to transfer $25. We withdraw the transfer from Jill's account. We'll put the transfer amount in Bob's account. And then we will just assert equal that the things are what we expect them to be. That Bob's account should be 125, and Jill's account should be 75. You mean if we wanted it to work like I just demonstrated? Yeah. Rather, you would change the design so that withdraw returned the current balance rather than returning void. Oh yeah, that's a good point. You're right. It should return how much. Yep, that's right. That's a good point. And then so that's a kind of conceptual error that'd be really easy to make. I just made it, and I could very easily, within the context of my code, have written return balance instead of return how much. But the test, you go through and you think through, well, how should this work? And the test wouldn't have worked as a result, and that would have focused you on where it is that you need to look for the error. Okay. So now one of the things that I wanted to demonstrate is I wanted to demonstrate overloading of constructors in the bank account. So a very reasonable thing that happens with bank accounts is you might want to start with a balance in your bank account. And so rather than starting with 0, we might like to create a bank account from the constructor in which we pass it in a balance. So we can do that by creating another constructor. Now you can't have two constructors that have exactly the same signature. What that means is a signature is a combination of the name of the method and the arguments that it takes. So this is giving me an error because Eclipse is saying, Java's saying, I've got two constructors with the same signature. You can't have that because if someone were to call that method, I wouldn't know which one to run. I wouldn't know whether to run the one on 7 or the one on 11. In this case, they're both the same, so wouldn't be a big deal. But what I want to do is I want to introduce the functionality of starting with an initial balance. And so I want the balance to actually be the initial balance that's passed in rather than 0. So now I have two different constructors. One constructor that takes no arguments and another constructor that takes an initial balance. And you can see that the behavior is kind of what you would expect. No constructor defaults to 0. Initial balance, you get an initial balance. Now Python didn't work quite this way. If you remember, the way that we did this in Python is we would have default values for the arguments. It's another way of going about doing this. Java requires you to specify different signatures for different methods that you want to override. This is an example of two different signatures for a constructor. You can actually have multiple signatures for anything that you want. So you could have a deposit function that takes different kinds of arguments. Maybe you wanted a deposit function that took how much, but maybe you wanted like a separate deposit function that did something like, yeah, or you wanted, I was thinking more like, let's have it so you deposit some dollars and some cents. And so what you end up adding is you end up adding dollars to convert it to a double by multiplying it by 1. And then plus cents divided by 100. So that would be another way of doing a deposit where you pass it in dollars and cents independently. I've now written two deposit functions, but they have a different signature because they have different arguments. Okay, do we know if it works? We don't know if it works yet, so we're going to go test it out. I'm going to take my test 2, make a new test. Now, I've already tested a lot of functionality, so actually let me let me just drive home the point that tests as they're currently written don't cover the code that we just wrote. So in this next test that I'm writing, I want to test out this constructor that doesn't start with 0. So we'll say 100. Okay, so I wrote a constructor that took an initial value, I deposited some money, and I made sure that it was what we expect it to be. Passes the test. I feel pretty good about that. But I have this new deposit method, so I want to test that as well. All right, so you can see that when I called it, I used the same method, but now I passed it 2 parameters, and they had to be integers instead of floating points. All goes well. It passed my test, and you can see I've got complete coverage now on the left side. You can run JUnit tests without doing EclEmma. You can just do run as a JUnit test, and if you do that, the testing part will work fine. You'll see this stuff over here, whether you passed a test or not, but what you won't see is you won't see the color on your code. And I think the color on the code is just a great visual indicator of what's going on in your code. All right, so that was we implemented almost 3 classes today. We did circle, we did the clicker, we did the bank account. What we did in the bank account that was slightly different is we did 2 different constructors. Generally, what a constructor does is it initializes the object by creating some memory for it, setting those instance variables equal to an initial data. We had constructors that had, the constructors have the same name as the class that we're implementing, and constructors don't have a return type. We implemented multiple constructors, and each one of those constructors had to have its own signature, otherwise Eclipse complains. And the signature is a combination of the name and arguments together. Okay, the last thing I want to show you is Javadoc, and then we will take a look at our homework, and then we'll be done for today. Okay? So Javadoc is a specific way of doing comments. And so what I'm going to do here is I'm going to write my comments out, and I'm going to do it using the double star method for doing comments. And you can see when I do that, Eclipse offers me a bunch of code completion templates. And so whenever you submit code to me, I want you to have Javadoc comments in there. So that means that there's going to be a comment at the beginning of the class, a comment at the beginning of each method, and you should really have a comment for each instance variable as well. So I'm going to just specify above here, I'm going to say this is a class that models a bank account. I would appreciate it if you could change any shorthand to your actual name. So that's going to be a Javadoc comment for the bank account, and then I'm going to say, if I do that and hit return, I get a template for me, and I could say this constructor creates a default balance of 0. Initial balance, I'm going to add to the end of that. I'm going to say the starting balance for your new account. Deposit will say, didn't do the right kind. I'm going to show you what you can do with it as soon as I'm done annotating everything. Okay, so for a comment, I'll say, this will add money to your bank account. The amount to add. So I'm describing that parameter, how much. All right, and so do the same thing here. Dollars, the amount of dollars to add, amount of cents to add money to your bank account. Great. All right, so withdraw the amount to withdraw. This will lower your bank account balance. All right, and then finally, when we do get balance, we're going to get a different kind of Javadoc annotation. It'll say return, so it's asking you what the return value is. Say this will reveal your bank account's balance. Return, we'll say the balance in your account. All right, so now I've annotated my class with Javadoc. There is a feature in Eclipse where you can generate your Javadoc. I gotta find it. There it is. Generate your Javadoc for your class. So it opens a wizard and it says, well, what is it that you're trying to annotate? And you can specify the class that you want to annotate. And I want to annotate everything in my bank account class. And I want to use a standard doclet. So what that means is what template do you want to use for your output. I'll show you what's going to happen here. You get some information here about things you can write. So I'm just going to say the documentation for bank account class. I better use no space since that's what it's called in code. Go ahead and finish. You want to update? Yes. All right, and now when it's done, in my project, I have this new directory called doc, that stands for documentation. And it's HTML, it's a web page. And if I open my index.html, it's created this whole interface that takes the things that I wrote in Javadoc and specifies it out. So I can click on the class that I have, and you can see it puts the package name. It takes my code here, and it says this is a class that models a bank account, spells out my author, lists all of the methods that are constructors, shows the difference between them, what their parameters are. Deposit, I click through, I can go to the withdrawal method and see, oh, withdraw, what does that do? This will lower your bank account's balance. The parameter is the amount to withdraw. So what the Javadoc does is it takes your public interface, what an application programmer needs to know in order to use your class, and automatically generates this really nice HTML page using those syntax that you put in there. It will only read comments that start with /**. So that's to your point. What's the difference? Javadoc only reads /**. Yes. Yeah, so what the Oracle website has in their documentation for Java is all generated by comments that are in the actual code for the implementation of all the classes. Yeah. Not globally, but when you work with a team of software developers in a particular organization that's writing software, you'll often have style guides that will answer that sort of question. Style guides about how you do indentation and how you name variables, but also how you write documentation and so on. And so forth. All right. So that's just really helpful for you. That's why the documentation for Java looks the way it does. So finally, let's take a look at the homework and what I'm hoping that we're going to accomplish, what you guys will accomplish with it. All right, so let's see. I think I've already got it up here. Okay, go. All right, so I'm asking you to write a class. You can go in Canvas to Chapter 3's assignment, and there's a PDF that actually describes it. Okay, and so I'm asking you to write two classes, one called letter.java and one called letterprinter.java. This is a real classic separation between an implementation and a usage class. So letter.java is the implementation, and letterprinter is the application of it. So what you're going to do is you're going to create an object that enables you to write a letter, like a thank you note or something like that. And what it's going to have is it's going to have a constructor, which you pass in a string that it describes who the letter is from and who it's to. You'll have another method that adds one line of text to the body of the letter that can be called multiple times. And then you're going to have another method called getText that's going to return a string, which is a formatted version of all the information that was passed into your object. And it should format it so that it looks like this when it gets printed out without the fonts. The fonts aren't important. But what is important to me is that you get the spacing exactly right, the colon exactly right, the comma after sincerely exactly right, and that each line is on its own line in the string. So it's going to take a little bit of work to make sure that the syntax for that works correctly. So that this is what it does, but within the letter class isn't going to call itself. The letter class is going to implement this. And then in the letter printer class, I want you to use those methods in order to print this letter to the console. So basically, I'm asking you to put a main method in the letter printer class, create an instance of the letter class, set the from and the to as John and Mary appropriately, and then call add line twice with the text, I am sorry we must part. I wish you all the best. Sincerely, Mary. And then when you call get text, this is the string that is going to return. And so you can do system.out.println letter.getText. Right? So here's a little bit more guidelines about that. And there's a little bit more information about where you might want to look for how to manage strings. Okay. What you'll turn in is you'll turn in 2 Java classes through Canvas, and I'll just evaluate them. And I'm looking for, I'm being very detail oriented on this one. I'm looking for Javadoc comments that are appropriate. Make sure your name is on there. I want to make sure that the text that's returned is exactly like that. So there'll be other opportunities to be creative. This is not one of them. Okay. What I really want you to do is just exercise this understanding of application programming versus implementation programming, and actually following requirements, because depending on what kind of work one ends up doing as a software engineer, you may be taking requirements from outside clients and implementing them, and you have to follow those requirements very exactly. You can imagine the requirements that a NASA software engineer receives have to be followed exactly, because it is controlling a rocket, or it's controlling the Mars lander or something like that. Depending on your institution, depending on what you're doing, the degree to which the requirements have to be followed vary. If you're making the burrito finder app, it's not quite as important that it follow it to the letter as it is if you're making the nuclear reactor software. Okay, so to summarize for today, we looked at a bunch of implementations of classes. We looked at a clicker implementation and a bank account. We worked with those classes and we tested them. We used the JUnit test suite in order to write the test. We used EclEmma to see code coverage. We demonstrated the difference between doing the implementation and the application programming. We looked at the ability, how you can override methods. We looked at the public keyword and the private keyword. And importantly, we tried to get our head around a little bit the way in which variable names are references to objects, and they can be referring to, multiple references can refer to their own memory, or they can be pointing to the same bit of memory, depending on how your code is organized. All right? Any questions? Anything from our Slack peanut gallery? See anything out there? All right, then that's it for today. Thank you for your attention, and I will see you actually in 3 days.